Okay, so we're going to look at relative frequencies. So hit pause, copy the lesson objective and keywords down. When you're ready, hit play and we'll move on to the starter. Okay, so here's our starter. Hit pause, have a go at all three questions. When you're ready, hit play and we'll go through them together. Right, so question 1. Sum of money shared between friends in the ratio of 5 to 3. The smaller amount is 120. What was the total sum of money? Well, if the smaller amount of money was £120 and it's 5 to 3, that means 3 shares is equal to £120. 3 shares equals 120. So 1 share is going to be equal to 120 divided by 3, which is £40. Now there are 8 shares in total, so 8 shares are going to be 8 times 40, which is equal to £320. That's one way of doing it. Another way is using the bar method, and if we break it up like so, let's see if we can get 8 shares in here. 1, 2, 3. 1, 2, 3, 4, 5, 6, 7, 8. That means if we have 3 shares equal to £120, each one is 40. But that means since we know each share is 40, we can fill all the boxes up, and 40 times 8 is 320. Okay. So, moving on to question 2. Factorize, double brackets, equal to 0. It's x squared, so it's going to be x times x. And we're looking for the factors of 15 that can give us 2. 5 and 3 is minus 15, so one of these has got to be negative. Because it's plus 2x, it's going to be 5 minus 3. So it'll be x plus 5 and x minus 3 equals 0, which means either x plus 5 equals 0 or x minus 3 equals 0, which means that x is equal to minus 5 or x is equal to 3. This one, as we looked at yesterday, is dots, difference of 2 squares. So it's going to be square number and a square term and a square number. 81. So 8 plus 9, x minus 9. 8. Sorry, x plus 9, x minus 9 equals 0. So either x plus 9 is equal to 0 or x minus 9 equals 0, which means x is equal to minus 9 or plus 9. Last one, product of prime factors, express 160. So if I have my 160 here, because I'm running out of room, just change color so it stands on its own. Let's go green. So I've got 160. I've got to factorize it. Now, prime numbers that we've got, put them at the top here. 2, 1 isn't because it's only got one factor. 2, 3, 5, 7, 11, 13. We'll stop there. And we just check, always check with the smallest number. 2 goes 80 times. Then we break the 80 down. We circle the 2 because it's prime. 2 goes again 40 times. Circle the 2. Break the 40 down. 2 goes into 40 20 times. Circle the 2. Break the 20 down. 2 goes 10 times. And 2 goes into 10 5 times. And 5 is prime. So we can say 160 is equal to 2 to the power of 1, 2, 3, 4, 5 times 5. So hopefully you got those answers. So what you need to do now is correct your work, or mark it, correct it, and rag it. Once you've done that, hit play, and we'll look at relative frequencies then. So relative frequencies are where we use a sample of the population, and then we use that sample to estimate the entire population, the probability of occurrences in the whole population. We often do this with an experiment. So there we are. We can obtain an estimate by using data, experimental or statistical. And this is our definition of relative frequency: the number of times that event occurs divided by the number of trials. So we've got two events here. The first one is an experiment. So we're throwing a die. The outcomes are 1 to 6. And here what's happened is, out of, I believe it's 250 throws, 1 has occurred 25 times, 2 has occurred 34, and so on. And if you look at 6, it's occurred 95 times. So it's clearly a biased die, 250 trials. So we can work out then the relative frequency of 1 occurring. And to work it out, you do 25 divided by 250, and that gives us a 0.1 chance of getting a 1. And then 34 out of 250 gives us a 0.136 chance of getting a 2, and so on. So we take the number of occurrences, as it says here, divided by the total number of trials, and we can populate the relative frequency column then. Okay, so that's based on an experiment. So someone had the die and then rolled it 250 times to see what occurred. You can also do it on data. So you could sit outside and watch the number of cars watch the cars going by, and then tick off the colors as they go by. Okay, someone's watched 350 cars go by, and then they've worked out the relative frequencies. So the chance of red is 50 out of 350, blue 80 out of 350, and so on. And you can see that silver is the most popular color. Okay, because well, a lot of people like silver cars. We see a lot of silver cars. That's got a probability of 0.37. Okay, so that's relative frequency. It's, straightforward, easy enough to understand. What's important about relative frequency is that we can use it then for a larger amount. So these are our experiments and data that we've just done. As we say here, the probability of the next throw being a 6 is 0.38, which is very high compared to every other occurrence. The probability of getting a 1 is 0.1. And with the cars, probability of getting seeing a blue car is 0.23. Probability of the next car being silver is 0.37, which is the highest in the population. Okay. So based on our relative frequency, which we've discovered, we're going to use that then to work out the likely occurrence of, say, getting a 1 or a 3, depending on how many times we roll the die. Okay. So we can use our experiment to estimate then, in this case, the frequency of each number for 1,800 throws. So if we throw the die 1,800 times, how many times are we likely to get a 1? Well, we know that the chance of getting 1 is 0.1, so we multiply that by 1,800. Gives us 180 times. And we same thing for 2. We know that the probability of getting a 2 is 0.136. So in 1,800 throws, we multiply by 1,800, and it tells us it's 245, and so on. And we can populate our table. And for 6, is 684 times out of 1,800 throws, we're likely to get a 6 based on this bias die. So what I want us to do now is to make some notes. So we need to put our definition of relative frequency in your books. We need to have our table, and then we need to use that experimental data to work out the estimate for 1,800 throws, so you'll need this table as well. Okay, so hit pause, copy those down. Once you're done, hit play, and we shall move on. One more example. Okay, so this is a similar situation here. We've got our data, which we looked at earlier, and we've got our relative frequency, which we work out by the number of times these cars occur out of the total number of cars. We're going to use this data then to estimate the frequency of each car color if 2,000 cars pass. So same sort of thing. Probability of red is 0.14 times 2,000, which is 280. Blue, we take our probability and multiply by 2,000, and so on, and we can populate our table as such. You don't have to write this one down, we've already got one example. So moving on. Okay, so let's have a look at this example here. We've got the bag contains an unknown number of colored discs. Rebecca selects a disc at random, notes its color, replaces it, and she does it 500 times, and then they record her. So she does her experiment 500 times, and the information is recorded in this table down here below. So all our information is here. She selected blue 8 times, green 85 times, red 200 times, yellow 159, and so on. So use this information then to find out the probability that Peter selects a red disc. So Peter is going to select now. So to answer A, probability of a red disc is going to be equal to red, the chances of getting that is 200 out of the 500. We can simplify that as 2 over 5. Okay. B, probability of a blue disc is given by blue is 8 times out of 500. You can simplify that. 4 goes into 8 2 times, and then 4 goes into 500 125 times. You can leave them as fractions, or you can simplify them into decimals, either. And then part C is slightly different. So for part C, the number of yellow discs Rebecca would expect for 1,800 trials. So the probability of yellow in the first instance is 115 out of 500. But how many yellow discs would she get? We've got our probability, so we've got to multiply that by 1,800. And when we work that out, you can use your calculator to work that out, you get 414. So that's 414 times she would select a yellow disc in 1,800 trials. Hit pause, copy this example down. Once you're done, we'll look at some questions for you to attempt. Okay, so I've just got the 6 questions for you. Page 608. Just questions 1 to 6. Good luck. I'll attach the questions to the assignment.